Hello, and welcome back to Summer Work Help for Calculus 1. In this video, we're going to be taking a look at question number 4. So for question number 4, the directions say, identify an equation whose graph satisfies the given criteria. All right, so 4a. 4a is talking about a line that has a slope of -2/3 and a y-intercept of 1. Well, this works out fairly nicely because one of the forms of an equation of a line is slope-intercept form, which many of you are familiar with. Y equals mx plus b, where m is the slope and b is the y-intercept. So we have exactly the information that we need in order to express this equation. So y equals m, my slope is -2/3, the x stays, and my b is my y-intercept of 1, and that is definitely an equation of a line that we can use. So for 4a, y equals -2/3 x plus 1 in slope-intercept form. 4b, a line that passes through 3, -8 and is parallel to another line with an equation of y equals 2/3 x plus 5. So we need to pull some information from what we're given. First of all, if the line that we care about, if it's parallel to this line, it means that it has the same slope, right? So parallel lines have equal slopes. So I don't want the equation of this line because that's a different line, but it is parallel. But that line that's highlighted, it is parallel to the line that we want, which means the slope of the line that we want is 2/3 because it has the same slope as the highlighted line. The other information that we're given about the line that we care about is that it passes through this point. So with a little bit of work, I suppose you could get the y-intercept here. However, slope-intercept form is not the only form of a line that we have at our disposal. We also have, very handy, point-slope form. So the difference with point-slope form is that instead of needing the y-intercept, you can use any point on the line, right? The y-intercept is a very specific point on a line, but with point-slope form, you can use any point on the line. Point-slope form looks like y minus y1 equals m parentheses x minus x1. Now, sometimes it's written like this. Sometimes it's written as y equals m parentheses x minus x1 plus y1. Basically, the y1 just got moved over to the right-hand side. And the version in red is used because it's y equals. So like on the calculator, you can type it in. But in general, point-slope form is the first version that we wrote. So x1, y1 are just the coordinates of the point on the line that you want to use. Well, we're told that it passes through 3, -8, so let's use that. All right, that's as good a point as any. So what I'm going to do is I'm going to go through and I'm just going to plug in these different values. So we have y. Now it's minus y1, and notice that y1 is -8. So when I subtract -8, I end up adding 8. So it's going to be y plus 8. As we said, it has a slope, or it's parallel to the equation that we're given, so it has the same slope of 2/3, parentheses, x, and then I'm going to subtract x1, which is 3, so it's minus 3. Now, The directions just say give an equation. It doesn't say that it has to be in slope-intercept form. Point-slope form is just as good for the purposes of this question. So we can stop there. Now, with a little bit of algebra, you can sort of modify this to be in slope-intercept form. But the directions don't say to do that. So I'm just going to leave it as point-slope form. And if we need to convert, then we can convert, but we don't have to. So for 4b, my answer is y plus 8 equals 2/3 parentheses x minus 3. All right, 4c. A line that passes through -4, 0 and is normal, which a little clue here means perpendicular, to a different line, y equals 3/5 x minus 1. So this question is very similar to part B. The difference is that now we're talking about a line that is not parallel, but it's perpendicular. And sometimes that's called normal. So here, we just need to remember how perpendicular lines, like how their slopes sort of interact with each other. Unlike parallel lines where the slopes are equivalent, where they're identical, perpendicular slopes, they're negative reciprocals. So notice that the line that we're given has a slope of 3/5. Right? And that -1 is irrelevant for this question. What I care about is the slope. The slope of the line that we're given is 3/5. The slope of the line that we're trying to find, therefore, I'm going to change the sign. So it was positive, so that means that the perpendicular slope is going to be negative. And then it's also the reciprocal. So the original slope was 3/5, which means the perpendicular slope is going to be 5/3. So again, I changed the sign and I flipped the fraction. So that is the slope of the line that we want. And we're told that it goes through this point. So all I'm going to do is I'm just going to use, once again, I'm going to use point-slope form. So that's y minus y1. Well, notice that here it's 0. So minus 0 equals -5/3, parentheses, x, and then it's minus x1. X1 is -4, so I'm going to add 4. And so that's my answer. I would say that we don't need the -0. So instead of rewriting it, I'm just going to get rid of it, right? If you leave the -0 in, kind of, I'm not sure if your teacher would mark that as incorrect or not, but we don't need it. So our final answer for C is y equals -5/3 parentheses x plus 4. And again, you could convert this into slope-intercept form by just distributing the -5/3, but we don't have to because it just says an equation, doesn't say slope-intercept form. All right, D. For D, we want the equation of a line that passes through 2 points. It passes through 2, -5, and it passes through 4, 1. So for this one, we need the slope, right? So anytime you have a line and you want the equation of the line, no matter what form you're using, you kind of need the slope, unless you're giving it in standard or general form, but we're not really going to use that. So whether you're using point-slope form or slope-intercept form, you need the slope. So we need to find M. So M is the formula for, there's many formulas for slope. They all mean the same thing, but one formula for slope is y2 minus y1 over x2 minus x1. So if I let this equal x1, I let this equal y1, I let this equal x2, and I let this equal y2, well, I can now go ahead and just plug in these values. So y2 is 1. Y1 is -5, but I'm subtracting it, so it's plus 5. Right? You're basically finding how far apart are these numbers. So if my y values are 1 and -5, well, the distance between them is 6. Right? So you're just finding how far apart are they. And then x2 is 4, and x1 is 2. So again, you want how far apart are the numbers 4 and 2. So my numerator is 6, my denominator is 2, so I get a slope of 3. Great. So now I have all the information I need to give my equation, and I just need to pick a point. Now I have 2 points. which means if I pick the first one, well, my equation is going to be y minus y1, which is negative 5, so it's going to be plus 5 equals my slope of 3, parentheses, x minus 2. That's a perfectly acceptable answer. You could also use the second point. The second point is 4 comma 1. Well, in that case, it's going to be y minus 1 equals the same slope of 3, parentheses, x minus 4. And so either one of these is a perfectly valid answer for D. So we got our slope, and then you just have to pick a point and then just use point slope form to give the equation. All right, E. E wants the equation of a horizontal line through the point negative 7, 6. So I've seen students struggle with this, and I would encourage you, if you get tripped up by this, because the equation is going to end up being very simple, but you'd have to kind of understand sort of how to get it. So if you do it just like me, either in your head or just off to the side, if you just do like a quick sketch, well, negative 7, 6 is like right there, right? So negative 7, 6, and it's a horizontal line. So I want the equation of this line that goes through that point. Well, notice that every single point on this line has the same y value of 6, right? Also, notice that the x value is kind of irrelevant because it's like it doesn't matter what the x value is. You just get a 6 as the y value, right? So all horizontal lines have their equation is just like y equals a number. That's it, right? So all horizontal lines look like that. And in this case, because it passes through negative 7, 6, right, that's the y value. And so it's just y equals 6. And that's it. That is the equation of that line, y equals 6. There's no x at all. Because, again, with a horizontal line, it's like x is kind of irrelevant. It doesn't matter what x is. You just get a 6 for your y value. So for E, your equation is y equals 6. F is similar. So F is a vertical line through 0, negative 10. And again, if you get tripped up by this, you just do a quick sketch. 0, negative 10 is right there. So it actually turns out, I'll do this maybe in a different color. So the equation that we're talking about is a vertical line. So it looks like that. So it actually turns out what we're talking about here is we're talking about the y-axis, right? What is an equation of the y-axis? Well, again, notice that on the y-axis, all of your x values are 0, right? So x equals 0. All right, so all of your x values are x equals 0. So I just wrote it, but I'll write it again. So the equation of this is x equals 0. That's the equation of the y-axis. All right, G. So for G, now for the first time in this question, we're talking about something that's not a straight line. So for G, we're looking at a parabola. Okay, so not a straight line, but a parabola that has a vertex at negative 2 comma 5 and a vertical stretch of 1/3. All right. So we can't use point slope or slope intercept form because this is not a straight line. This is a parabola. Parabola is the graph of a quadratic function. So we have this handy thing called vertex form, which certainly seems like it might be helpful here. Vertex form looks like this. Y minus k equals a, parentheses, x minus h. Now, if I stop there, it looks pretty similar to point slope form, right? We replaced the m with an a, we replaced x1, y1 with an h and a k. But crucially, the difference with a parabola is that you have a squared on your x minus h. Okay, so that's what kind of it makes it a parabola, right? Because if you don't have that squared, it's basically a line just with some different letters, but the letters are quote unquote arbitrary. So you need that squared there to indicate that it's a parabola. So in this case, A is the vertical stretch, and then h comma k is your vertex. So we have all the information we need. So we have y. The y coordinate of my vertex is 5, and I'm going to subtract it. So it's minus 5 equals my vertical stretch, which is 1/3, parentheses, x, and then I subtract the x coordinate of my vertex, which in this case is -2. So when I subtract it, it becomes +2 squared. And then that is an equation of this parabola. Part H. You want a parabola that has x-intercepts at x equals -9 and x equals 7. So in this case, what we have is we've got these two x-intercepts. So when you're given the x-intercepts, you can just write your equation like this. You can just say y equals, and what's going to happen is you're going to give your equation in factored form, okay? So it's just like the previous one, just like g, it is going to be a parabola, but we're just going to use factored form, or intercept form. So what we can do is we can take each of our x's just like that, and for each x-intercept, we're going to basically just like flip the sign, okay? So for the first one is -9, so my first term is going to be +9. Because what I want is when you plug in a -9, you want to get a 0. So if you let x equal -9, you get -9 plus 9, which is 0, and that's what we want, right? Because it's an intercept. Likewise, with x equals 7, if I say x minus 7, like that, well, again, when I plug in a 7, I want to get a 0, and that's going to be my my x-intercept. And I guess it's a little vague because you could have a vertical stretch here. You could have an A, but it didn't mention anything about a vertical stretch, so I'm just going to leave it like that. But we could have a vertical stretch here, but the question didn't indicate what our vertical stretch is, so that's good enough for now. So I'll zoom out here so we can see everything. But that is question number 4.